All right, so gotta keep practicing. This is tough work. I'm doing a function that is y equals -2 to the x minus 2 plus 1. This is an exponential function, right? 2 to the x. So we know the inverse that we're going to graph is going to be a log. And we're going to use this to make our inverse, all right? And they're showing the y equals x. And the first thing is it wants to do the points. But I am going to start with, let's record some data about our exponential up here for f of x. And I'm doing that right here. So I think f of x, it definitely goes forever. It doesn't go forever on the x's, it looks like, right? It goes on and on, so it's going to be all reals. So we're going to write that as -infinity to infinity. And it obviously has a horizontal asymptote, right? Because exponentials, 2 to the x has that, and I can see that it's at y equals 1. So the range is -infinity to 1, and that horizontal asymptote, y equals 1, is shown there. All right, so we got that. That's going to help us later, all right? Now I'll make a line. And before we move the points, I'm actually going to solve this for x now. So I got y equals -2 to the negative x minus 2 plus 1. I'll move the 1. And everybody, this is a case where you have to get rid of that negative right now. So I'm just going to multiply by a negative. Boom, boom, boom. And then when I rewrite this, I have -y plus 1 equals 2 to the negative x minus 2. 2 to the stuff equals n. 2 to the L equals n. We can rewrite this. So we can write -x minus 2 equals log 2. And then it's -y plus 1. I'm going to add the 2 over. Cross that off. And then everybody, I got to put the negative on there. So all the things have to change sign, including the log just in the front. Because once you get this, the inside doesn't change. It's an argument is what we call it. And we get here. So my inverse function, when we get to that point, -1 of x, is log 2, -x plus 1, minus 2. All right, let's move some points and then we'll be able to enter this. So I'll go back to moving points. And again, I'm just looking. This is -2, 0. So I got to go 0, -2. This is -3, -1. So it's -1, -3. -4, -3. -3, -4. This is -5, -7. So it's -7, -5. I think I missed. -5. Well, we'll see. No, that can't be right. It must be a little, it's got to be there. Let's try it. Nope, I missed. Let's make sure of this point here too. So this was -4, -3, so it's -3, -4. This point here is -5, -7, so -7, -5. I just missed. So I got it now. And now I'm going to scroll up and we're going to use this information. I'm going to yell from the computer again. All right. And when I get to the computer, I should be able to do this work for us. All right. So the first thing, I've already done it. The inverse of the function, right? We had y equals, we solved it for x. So now I just input it. And we know it's negative, and I got to use the log 2. -x plus 1 minus 2. All right, the original function had a horizontal asymptote. So that means y equals 1 turns into x equals 1, which is a vertical, right? A vertical line. The range, well, the domain of the original function is -infinity to infinity, so that is the range, right? X and y flop. And I can tell looking at this, the dotted line is increasing. And the range was -infinity to 1, so that becomes the domain. -infinity to 1. Guys, that is it. These are tough problems. They take practice. Keep working. All right, you're getting better at math every day.